All right, so I wanted to look at the window installation and how the bands relate on the upstairs in the frame here. So, a couple of nice things. They have a flat return for the window. They gave it good spacing for a backer rod and sealant here. They've terminated the band underneath, a band up here, and they've sealed those joints, so that'll be good. They have a metal flashing here. That's something I rarely see that really is required. And I would say this is pretty good. If it were me, I would have done a couple of things a little differently. One, the head flashing terminates at the edge of the window. I would have carried it out at least an inch and then turned it down on the end to help protect that end right there, because that needs sealant in it now to keep water from getting behind it.
Water intrusion issue there.
Okay,
yeah.
But at least if water gets behind this band, it hits this metal flashing and comes out over the window instead of in it. That's what the intent of that. They just need to do something with these corners. Okay, they could have carried it all the way out here and just finished this bead to the underside of that. That would have been perfect.
But right now they got to put some sealant in there?
Right now that needs to be sealed right there.
Okay,
yeah.
Okay.
Both sides.
Gotcha.
So that looks good. Now, I'm a big proponent of moving these decorative bands to the surface of the brown coat, because that way you get a solid watertight or water resistant finish all the way to the edge, and then you put a band on the top of that, and if water gets behind it, it's going down the brown coat and it's not back at the substrate. Now that works a lot better on solid bases than it does up here, because you still have to isolate the window. So you'd still have a plaster stop and a backer rod and sealant here. You'd move the band out further, it wouldn't be as deep. But that would work better, because then you don't, if you get a leak at these things, water is automatically on the drainage plane. If it's out on the brown coat, it's still got to go through the brown coat and the scratch coat to get to the drainage plane, and then it's only to the bond break. So it kind of works like this. Since December 16th of 2005, you have been required to have 2 layers of water-resistant barrier on the house. One can be a plastic house wrap, and the other one can be this black paper like you see, or it could be 2 layers of black, it could be 2 layers of house wrap. However you want to do it, as long as you got 2 layers and they meet the standard. Okay? I prefer to wrap the house twice and then use plain lath. When you get to the WRBs, when you get down to this, which is the weep screed, this is a foundation weep screed, is what you'd use here. Then the paper and the WRB has to go over the face of this flange like this, because if it goes behind, then the water's going behind. You want it to go over here so that it weeps out off of this shelf. That's the intent of this piece. But if you have a control joint that meets a weep screed, can you see this now? Where it dies into it like that. The paper up here has to go behind the control joint, but down here it has to go over the flange. So if you're using paperback lath, the only way to do that is to tear or cut the lath right here and make a seam, which is another penetration point. So we don't want to do that. That's why I prefer wrapping the house twice and then putting it up here like this is done. It all works out perfectly. Okay?
So Mike, the bottom of this weep screed here, this goes over the wall flashing for the shingles.
Yeah, so what Bob is saying is that the weep screed, this bottom edge of the weep screed, has to be down over the top of the angle flashing at the roof, so that if water does get there, it's already below the seam of the flashing, which should be up here. In this case, it's done right. The other thing to notice is that there are holes drilled in the bottom of this. These are not for weeping, even though they call them that. These holes, these tiny little holes here, are a manufacturing thing, and therefore they create a mechanical key for the plaster and plane, so that when it gets down here and comes across there with no support, it won't edge curl. It'll push plaster down into that hole, and that will hold it in plane so it won't edge curl as it dries and shrinks. The other thing we haven't really talked about, and I doubt if you can see it from there, is fasteners. This is a staple. They have to be corrosion resistant or galvanized. They have to have a crown of at least 3/4 inches wide, and they have to have a leg sufficient to penetrate the framing member by 3/4 of an inch. Now that means that leg has to go 3/4 into the stud, 7/16 or 1/2 inch through the sheathing, plus another 1/8 for the lath and the WRBs. So you need a minimum of 1 3/8 inches to do that. They don't make 1 3/8 inches, so you got to buy 1 1/2 inch leg staple.
Good point, Mike.
Again, like we said earlier, if I was going to do these bands, I'd do the top level with an angled bead. I might do the whole thing with an angled bead so that if water gets on that shelf, it comes out. What I don't see here is a pan flashing, and I can't tell if it's in there or not. But it would be similar to the head flashing, except the end dams would turn up. But it would come out and drip over the face of this. It would come out underneath here and be over the top of that band, so that it delivered water to the exterior face of the wall.
So is that a requirement for the standard?
Flashing that window is required for the standard. How they do it, there are different ways to do it, but pan flashing is the best, yes.
Okay.
Absolutely. And I would, if I was the designer, I would require it,
Okay.
yeah. Okay, what else we got up here? You have a nice kick out here, good depth. This one I really like. This kick out flashing moves water away from the wall. This one's extremely long compared to what you usually find. This one will work. Most of them are cut so short that the wall's still getting wet right here. I know you can't see that from here, but this eyebrow was cut back. There's a good 1.5 inches. I can get 2 fingers in there sideways between this subfascia and that wall. This can be plastered behind it. That's a good one.
This is not tied here, Mike. You see a tie? Oh, there's one right there.
Okay.
Okay.
Actually, it's one they don't even need.
Yeah.
It's a good place for it
Yeah.
because of the change in the geography and the geometric shape.
Yeah.
So they've added a weep screed here, the purpose of which is to separate the geometries here from this square to this parallelogram up this way. That's my college lingo for the day. I'm not going to use it anymore. All right, so it separates those shapes because this would tend to crack across here if it didn't, because of the shape configuration of it as it dries. So that was a good catch that they did there, and a smart move. A minute ago, Bob pointed out something I didn't catch earlier. I'm glad he did, because this is an issue. You see here we have a wood beam with lath and WRBs over it, and a mid-wall weep screed comes into here and then stops. So out here you've got metal, paper, and then the flange of the mid-wall weep screed. That is wrong. That paper has to go behind the flange of that joint, of that weep screed. In here it's okay, it continues up. But out there you can't do that. That's a problem. That's gonna let water in there. So
it's gonna rot.
So that one needs to get fixed. You know, it's a minor in a small place, but look where it is.
Right there.
Right underneath the kick out flashing. So that's one place you don't want it. Okay. All right, then we were going to talk about these box beams. And we talked earlier, I think, about, or we may not have, the way this is boxed in and the separation here. So wherever you have vertical plaster abutting horizontal plaster, they have to be separated. Now, if it's on the inside face where it's not weather exposed, you can do that with 2 plaster stops, one the other, and you're good to go. But on the outside face, there is a code requirement for the vertical face to extend 1/4 inch below the horizontal, and for them to be isolated by 1/4 inch minimum, separated by 1/4 inch minimum, so that you can get a backer rod and sealant into it. Because in this instance, the drainage plane is here on the outside face of the stop. Now, I would probably use a weep screed here or a Z flashing here instead of a stop. But this can be done, and this does work.
Would be better.
Okay? The drainage plane is out at the surface out here, not behind it. So you're going to create a gap at the horizontal when you put in here. Now, they don't have enough of a gap in here. It's butted tight. There needs to be enough gap that you can put a backer rod and sealant in there. You can't leave it open because wind-driven rain will go up in that, but also because if you leave it open, you've created a bug run, and you don't want to do that. So that one has to be isolated and separated so that you can put a backer rod and sealant between it. And the vertical should be 1/4 inch below the horizontal. On the inside face, it doesn't make any difference. It's not going to get direct rain. If you do have a gap or a separation, you got to seal it. But other than that, you know, this technically won't do it. It does provide a drip edge, but it doesn't isolate vertical from horizontal. All right, so on the inside face where it's not weather exposed, corner bead still doesn't cut it, but you don't have to go to that extreme either. Okay? Now, when you're wrapping these boxes, and this has become a real issue, not so much on these porch beams like this, but I'm going to use this as an example, as it is on bump outs on the second floor where the floor is cantilevered out a couple of feet and they have a breakfast nook or something up there, you know, a sitting room or something sticking out. What's happening is they come along and they house wrap the house. They put the house wrap on, they come around, and if they wrap it twice, they put the wrap on, then they go, oh yeah, we got to do the bottom of this too. So now they come back and they put another layer and they go from here around to the inside. And what they just did was create a reverse lap on the outside, and they've built a boat down here to catch the water. Okay? And so we're finding extreme amounts of failure in this condition on the bottom side where the trusses and the sheathing and everything is completely rotted out. And in one video we had recently with a layer of house wrap there, and it was hanging down, and the guy took a sharp rod and poked a hole in it, and water poured out of it for 5 minutes. Whoa. I mean, it was full of water. And that's what happens when you make a boat like that. If you're going to do this, you have to do this inside area and up the outside first, and then wrap the rest of the house so that it's over it. Otherwise, you got a reverse lap. Now, because it's become such a problem, some of the house wrap manufacturers are now saying that if you're doing this, you must cut slits in the house wrap on the bottom along here so that if water does get behind it, it has a way to get out. Frankly, I don't like that. I would prefer we teach them to wrap it properly to begin with and not have that issue.
That's going to be constantly wet.
Here we're looking at what is probably either a dryer vent or a bathroom. I think this is a dryer vent, one location of it. Doesn't matter, bathroom vent, dryer vent, whatever's coming out of a wall. So they've made a grand effort to isolate this and seal it with the plaster stop, cut at the right places and bent around, and then this. But there's no way to seal this. You're not going to get a proper configuration of a sealant bead, which, by the way, needs to be an hourglass shape so that it bonds or sticks to two sides, but not three. If it sticks to three-sided, if it has three-sided adhesion, the bead will stretch itself in two different directions and tear itself apart. So the reason you use backer rod is to keep it from bonding to anything else. So it's going to bond to that and bond to this. You know, in this case to the side over here, it won't do it here. But this is going to be, you know, out and then up. That's not going to be a correct configuration, and the sealant manufacturers will not warrant a sealant bead that looks like that. So what's wrong with this?
So why do they even do that?
What's wrong with it is this. There's a pipe, a conduit that comes up, a vent stack comes up out inside the wall or out through the wall and connects to this cap. This cap is designed to go over the surface of the wall finish, so on top of the stucco. So what should happen is the pipe should be brought out far enough to get beyond the stucco, then flashed and sealed. Then you lath it, wrap it, lath it, and plaster it, and then you can seal, you isolate it and seal around it, and you'll have, there's a return up here, you'll have a place to finish that too. Okay, so these are designed to be surface mounted, not wall mounted.
Cap on.
Pardon?
The last part would be put the cap.
And then you have to come back and put the cap on it, and then you seal around that.
Yeah.
So we have an issue then with the electrical over here. I made a comment earlier that the fact that it stands, the pipe stands away, the conduit stands away from the wall, helps the plasterer because he can reach behind it. But the truth is this: the easiest fix for this configuration is there's a 90-degree elbow that comes out of that hole up here. If that 90-degree elbow was set so that that box was a 1/4 inch off the face of the stucco, you wouldn't have this issue. So they just need to bring that pipe out farther before they bend it down and offset the box the same depth, and you'll never have an issue with it. You can plaster right behind it. The holes can be sealed prior to plastering. Everything is easy. This, however, you know, is a valiant attempt that's not going to work forever. Fortunately, that box itself is plastic and not metal, so that's not going to cause rusting, but it will eventually fail and create a water leak point right there. And so that's a hard thing to do, but they need to train the electricians and put it in a detail for them to offset that from the surface of the wall face a certain distance to accommodate plastering behind it, and then they don't have a problem. They can just seal that round penetration and you're good to go. Makes it real simple. Okay? That's all I really have. There's an attempt at this eyebrow over here, if you can turn and see that, Kurt, but and it's pretty good, but they isolated part of it, but not all of it, and so now you've got an issue with a gap there that needs to be fixed. But at least they've cut that subfascia back so the plasterer can get to it, and so it's a start. It's one of those things that we have to train these guys over time to do correctly. We need to give them the detail so they can see it, and then train them to do it correctly. It will take time to get that changed, but as Paul said earlier, when he and I are, you know, we're up there, we're long in the tooth, and when we started in this business, that was a common occurrence. They always left them short like that. I don't know how we lost that, but we did, and we've got to go back to it. All in all, this is not a bad job. There are some specific things I would change. Again, they've come in and sealed this where they shouldn't. I would not do this way. I would not do that way. There's some little things like that. But to say that it's the only one in the county that way it would be wrong, or in the state that way, because there's thousands of them. And so it's a matter of training and teaching and getting the proper detailing. So let's discuss that for just a second before I crawl down or fall down. And
then we want to talk about the mixing of the stucco.
Yeah, next we're going to talk about application issues and mixing and that kind of thing. We've done prep now, but in the part of prep is plans examination and that kind of thing, and design and details. In the residential code, and forgive me if I get the numbers wrong, but I think it's 10247. There's a clause in there that says that we're not going to repeat all of Chapter 1 of the building code. We're just going to put this sentence in here that says everything in that chapter applies to this code. Well, in that chapter, there's a list of things that have to be detailed, and in that is all penetrations, all weather-tight seals, windows, doors, anything that goes through the wall has to be detailed. I promise you there aren't 3 builders in the state of Florida that are including those in their residential plans, and so it's not getting done. If they were there, a lot of the issues that we're having would disappear because guys would learn to do it right to begin with, and we'd be okay. That's my soapbox on that for today.
Okay, Mike. So we're here at basically we've looked at the house. We've talked about the situations that can happen that you've pointed out that there's different ways of doing things and looking at it and applying the standard to make it work. But here now, let's talk about one of the most important parts is the stucco itself. So, and the requirements of 926, ASTM C 926. So Mike, go ahead.
All right, so yeah, we have a nice pile of sand here. This is natural sand. It's been washed at the mine, that kind of thing. This is nice and white stuff. And if you look at it closely, you'll find out that there's different sizes of granules there, aggregates there, and that's good for stucco. You want a diverse aggregate sizing to lock it all together. Masonry sand is much more uniform than that and a lot finer, and does not work well for stucco because the finer the sand, the more grains there are. The more grains there are, the more cement it takes to bond all that together, and the more cement it takes, the more water it takes. So you've done 2 things. By adding water, you've increased the shrinkage potential of the mortar mix because that volume has to go somewhere. And by adding cement, you've increased the crack potential because it's a richer mix that will shrink more, okay? So there's a couple of things there. So in Florida, the standard allows you to use either Portland cement and lime mixed together, or Portland cement and masonry cement and lime mixed together, or a bunch of different things. But there's also one called stucco or plastic cement. This is an example of it. In Florida, we want you to use stucco cements. They were designed in Florida, developed in Florida, and meant for the Florida climate. there are manufacturers here that make stucco cement and masonry cements based on the quality of the limestone mines they're sitting on, are some of the best masonry and plastering cements in the world. So we're very fortunate in Florida to have really good quality products. So then you have a choice of doing a neat product like this, which is strictly the cement, and it's job mixed, where you have a mixer and a sand pile, a bag of cement, and a garden hose, and you measure your water and your sand, and you dump in your cement, and you mix it, all right? Now, there's a specific way you should do that. But before I get to that, there are other ways that you can also buy pre-blended, where the sand is already in the bag. It's very handy. It guarantees you will get a correct sand to cement ratio. But at the same time, it's brutally expensive compared to this. I'm talking 4 to 6 times the cost for materials. Okay, so you have to look at what it is. It's great for high rises and tight sites, that kind of thing. But for a place like this, I would do this or a silo application. So you can do cement and lime, or you can do masonry cement, or you can do stucco cement. I prefer you use stucco cement. I prefer it in a neat. And then there are different mixes. So what you're trying to achieve is, as you come away from the wall in the scratch and the brown coat, you want to get weaker as you come away from the wall, or equal to. So the standard has a table in which it has the scratch, brown, and finish coats and the allowable sand cement ratios for that. But if you look at those tables and you combine them, you'll find that you can go down to as low as I think it's 2.5, maybe 2.25 parts of sand to 1 part cement. And you can go as high as 5 parts of sand to 1 part of cement, depending on what you're doing. And it also will depend on the gradation of your sand. The plasterer will know what's best. But these products are bagged so that you use a 3 to 1. It's intended to be used in a 3 to 1 ratio. Well, 1, it's right in the middle of the scale, and 2, 3 parts sand to 1 part cement falls into all 3 categories: scratch, brown, and finish mix conditions. And you can use that 3 to 1 ratio for any coat you want to use. That's why it's done that way, to make it more versatile, okay? Now, is that sand to cement ratio that big a deal? Well, when you can look at it from this standpoint, that if you can go from 2.25 to 5 anyway, how can it possibly be that important? And while it's important, I really don't think it's as important as some people give it credence to it. So here's the deal. If you get too much sand in the mix, the plasterer is going to be out here jumping all over the guy mixing the mud. And the guy mixing the mud is always the rookie on the team. All right, it's one of the most critical jobs, and it's the one they give to the rookie. So the guy is mixing the mud out here. If he puts too much sand in it, the plasterer can't use it. And he's going to come back and say, dude, wake up. Cut down the sand, you got way too much sand. If he's not putting enough in it, it'll be so stiff that they can't move it. It won't work. It's no workability to it. Right? And again, he'll be out here jumping all over the guy mixing it. So really, job mixed sand cement ratios are not as important as they really sound, but it can be. I've seen issues where the sand cement ratio was so rich that it's like under 2 parts, and of a very fine sand, it just was a nightmare. It just didn't work at all. But it's rare. More often, the problem you have with mixes is that they don't let it mix long enough, because there's a specific sequence you go through. So what you're supposed to do is put half of the water, most of the sand in the mixer, and let them mix for a minute to get wet. Then you add the cement, and you let that mix. Then you add the rest of your sand and however much water you need to get it the consistency you're looking for. Now, the reason you do that is that cement is hydrophobic, and if you dump cement into just plain water, it will lump. And then they'll call up and claim that there was lumps in the cement. Well, there wasn't. You mixed it wrong, okay? So the sand breaks those lumps up. That's why you do it that way. But the way to really do it is this. They say when I say 3 to 1, we're talking about cubic feet. A bag of cement is 1 cubic foot, okay? Sand, 12 by 12 by 12, is going to weigh over 100 pounds. OSHA doesn't want you lifting that. So to have a 12 by 12 by 12 cubic foot box made to put your sand in to dump into the mixer can create a back issue problem for you. So although that's really the way to do it. So what we recommend you do is this. Every job has 5-gallon buckets. 5-gallon buckets are 2/3 of a cubic foot. So 4 1/2 buckets is 3 cubic feet, or is 3 cubic feet, okay? So if you're going to use a 3 bag, a 1 bag mix, you're going to use 4 1/3 buckets, and you'll have a 3 to 1 mix, okay? So the way you do that is you take your shovel in the morning, most of them are using a number 2, a square point shovel, and you fill that bucket, and you count the number of shovels it takes to fill that 5-gallon bucket, all right, and you dump it in the mixer. Then you just fill the bucket, and then after you take a break, or you go to lunch or something, you come back in the afternoon, particularly in this time of year and it's hot and sweaty, that shovel doesn't get quite as full every time. So you calibrate your bucket, you calibrate your shovel. How many shovels is it going to take me after lunch to fill that bucket? And you do that number of buckets from there. And you'll always stay in that range. You'll be real close, you'll be in a legal range. That's the way to handle it on the job site, just a practical tip. All right, you have to put it in there, and you're supposed to let it mix for 3 to 5 minutes. This is a requirement of the C926 standard, 3 to 5 minutes after the last ingredient goes in. So that really means the water, which is generally the last thing. But if you wait 3 to 5 minutes after you get the sand in there, you'll have a much better mix. Why does it have to do that? Well, one, it needs that time to coat all of the cement particles to coat all of the sand particles, all right? Secondly, as it whips, as it turns in that mixer, it whips air bubbles into the mix. And air bubbles, there's air entraining agent added to it, so it'll do this. It's like putting dishwashing detergent in the mix. And in fact, in the old days, that's what we did. We used a little squirt of Lux liquid in the mixer to make it fluff up like that, because as it fluffs up, it makes it real smooth and buttery going on the wall. Okay, it doesn't drag, it just goes right on there. So you're looking for an air content. Now the standard has a limit on air contents, and in stucco it's going to be like 22% is the absolute highest you can go. Most of them are going to be geared to make around 20 so that they don't go over it. Masonry cements are a little tighter than that. They're going to be 12 to 15. But that air makes it buttery and smooth and makes it go on the wall easier. So it's not so hard to work with. So the longer you let it mix, the more air it will build into it. So you don't want to turn the mixer on and then go for lunch for an hour and then come back, because if you do, it'll build so much air into it that it'll come out of the top of the mixer. So you don't want to do that. But 3 to 5 minutes will do it. I think if the standard said 5 to 8, we might get 3. But typically what happens is, as soon as everything is green, changes color in there, they dump it out, and it isn't ready. And that causes more problems than anything, because you can't properly densify it, things like that. So application issues, you go on the wall. This block wall has to be wet when you put the plaster on it. So you're supposed to come out here, clean all this latent material off of the wall, pressure wash it, whatever you got to do. Then you're going to wet that wall down, let the water soak in, and immediately start plastering it with a scratch coat. Come out about 3/8 of an inch, scratch 1/4 off horizontally. Then you're going to apply your brown coat. If the scratch coat has dried off, you have to wet the brown coat, the scratch coat, before you put the brown coat on it. And the same thing with the finish coat. When you show up to do the finish coat, you wet the brown coat before you do. That does 2 things. When you're laying unit mortar, when you're laying unit masonry, and you've got the mortar going on that dry block, it's a dry block, you can't wet that block first. Because they want it to bring that cement paste in, it's a structural issue for that. Right. The other thing is it's an inch and a quarter deep at minimum, and so you have the inside core is not affected by the weather. On plaster, on the other hand, is only 3/8 of an inch deep in a coat, and it's spread out like this, so the weather is exposed to all of it. So it dries out a lot faster. So you wet the wall so that it slows down the absorption process and leaves some of that water in the plaster long enough to get it to start curing and get that initial set. Then when you get that done, if you're going to scratch today and you're not going to brown for another week or tomorrow or whenever it is, go back and hose the wall off, because curing is a requirement of the standards. Curing is moist curing, and the best way to accomplish it in Florida is to take a garden hose and hose it down in the morning and hose it down in the afternoon. And I don't mean fog it, I mean wet it till it starts to run off. Give it the water it needs to finish curing. There's an interesting thing about cementitious products, particularly concrete. Once you put them down there, if they're not covered, they will continue to get hard for the life of the slab, as long as they're exposed to moisture in the air. Right? And there are streets, a study did where they tore up some streets in a certain place. They were 75 years old and they were made with hand-mixed concrete. at 2,500 pound concrete, and when they broke them, they were 12,500 pounds 75 years later. You know, so that's what concrete will do. Stucco will do the same thing if you don't paint it. If you let the moisture get to it long enough, it will do that. It doesn't need to go that long. So when can you paint the stucco? Well, this is not a matter of, oh, well, it's got to cure for 28 days. 28 days has nothing to do with how long it takes to cure cement or concrete or any of that. What that has to do with is a benchmark to measure other cements against in other parts of the country. So if you use this cement here and it does this in 7 days and 28 days like that, and you use a different cement over there and it does it, you have some standards to benchmark from. That's what that's for. All right. Yes, even exposed to the weather here in Florida, it should be fully cured in 28 days, but it depends on when that is. If it's January and we don't get any rain and all we have is dry wind, it may not be cured. So how do you know when to do it? Well, you take a pH pencil and you do a test of the pH in the surface of it. You go to look at your paint, whatever paint you're using, on the back of that can and the instructions, it's going to say, do not apply this paint until the pH is below X. And it may be 9, it may be 10. Most of them are 10, but sometimes they're 9. You got to look. And because the lime, the naturally occurring lime in the cement will burn the paint. It's called saponification, or lime burn. It will burn the paint, and it will cause it to be mottled and gray and eventually peel off. So it takes the color away from it, the sheen away from it. So you got to let it cure to the point where it's below whatever that rating is on the can. Then it'll say, unless you use our super fast primer, hot primer they call them, and you can put that on fresh masonry and paint over it and the paint will be fine. And that's true, the paint will be fine, but what you've done is stop the cure of the plaster at that point, because now you've sealed the plaster on the face so it can't absorb the moisture out of the air, and it's done at that point. So that's not a good thing. Those hot primers are great products, but use them as regular primers, not as hot primers. Okay?
That's a great point, Mike. From a perspective of installing lath and mixing it and doing it the way it's supposed to be done to the standard is not an easy thing unless you're trained to do it properly and to know what you're doing. So there's a lot of ways to make mistakes, a lot of ways to not apply the lath properly, there's so many things that's involved with a proper lath installation that it can easily go awry. So it's how important it is for an installer to know what he's doing and to know the standard and to basically do a good installation. So Mike, I want to thank you for taking the time.
Always a pleasure,
You're so gracious coming out here and doing that with us. And I'd like to give a point to Paul Watson, our building official, for allowing us to do that. And we will see you on the next video.